Hello friends, how are you? I hope you are doing well at your end and also staying safe at home, similarly following all the precautionary measures given by government. Let us start our chapter named as Design of Shaft. This is topic number 1 of Unit 3. These are your major topics of the study. You will cover first shaft basics, applications, types, stresses developed, types of shafts, then shaft design based on rigidity. Here we will try to cover solid as well as hollow shaft. Then the shaft design based on strength, where we will again include solid as well as hollow shaft. Then this is again a one more part of the strength based design, where shaft subjects to bending as well as twisting. We'll try to cover Mohr circle, which is already known concept you studied in strength of material, and these are the major topics of the study. This can be our lecture plan, however this is tentative, but we'll try to follow in a similar way. We'll start with shaft basics, and then we'll try to cover the shaft design based on torsional loading. Then we will cover shaft design based on bending, then combined bending and twisting, and shaft design based on rigidity. We'll try to solve few examples also. At the end we'll have a final design of shaft. So the shaft, basically the component is very well known to you all. You can see the figure of centrifugal pump here. This is a motor. Now this motor is attached by means of this shaft. Okay, this is the shaft and it is attached with the impeller, and motor is rotating and it is transferring power by means of pump to the impeller. So ultimately the water can go up, okay, through this pump head. So this is the assembly where you can see the practical application of shaft. Similarly, the same type of understanding you can create through this figure also. This is also the centrifugal. This is also a centrifugal pump. Here also you can see this is the motor part, and motor part is connected by means of this shaft to the impeller. Then so basically you can understand shaft is trying to transfer motion or trying to transfer the power from one component to the another component. So the term transmission shaft usually refers to the rotating machine element, circular in cross section, which supports transmission elements like gear, pulley and sprockets and transmit power. So here these are two words are very important. One, it supports the elements like gear, pulleys and sprockets, and also it transmits the power. Usually it is a rotating machine element, and generally it has a circular cross section. Here also similar understanding you can make from the again the centrifugal pump, right? So this is the part of the centrifugal pump. This is your shaft. Now shaft is supported by means of bearings. This particular member is known as bearings, and this is a shaft. You can see the configuration of shaft. If you compare with this particular solid shaft figure, then shaft has different types of diameters. So this we call it as a stepped shaft, where shaft has different diameters. Usually in the center, okay, the shaft has highest diameter compared to other ends, and sometimes to save the weight, if the strength is not the issue, to save the weight we will make the hollow shafts also. So generally shaft supports in terms of in bearings, and it rotates a set of gears or pulley for the purpose of power transmission. So this is basically a definition of shaft. Similar understanding you can create through this metal pump. Okay, here also this particular red color member is known as shaft, and you can see these are your bearings. Okay, in MD1 subject you are going to study the design of bearings also. Similar application is related to gear. You can see this is the part of gear. Okay, and this is the part of shaft. Shaft has again at one end gear. Now this gear is connected to the another gear. Now another gear is supported by means of the another shaft. This is also the shaft. So this is the second case where shafts are used. Now let us try to understand the type of shafts. So the first one is axle, second spindle, third countershaft, four line shafts, five spline shafts, and six transmission shafts. So let us try to discuss one by one each shaft. So first one, axle. You already know about this axle. You might have heard about axle used in automobiles, the rear axle or front axle. It is defined as a non-rotating member used for supporting rotating wheels, hoisting drums, rope seals, etc., and do not transmit any torque. However, this is applicable to only few of the cases. So, if axle does not transmit power, if we take the example of railway wagon, then it will not transfer the power. But if we take the example of automobile, then definitely it will transfer some power. It may rotate with the wheel or simply support the wheel. So generally, axle only subjects to bending, and usually this bending will come from the obviously from the bearing reaction. You can see this photograph. Okay, the photograph is of the automobile rear axle. So the whole part now here definitely it will transfer some torque, and it is not a non-rotating member. So basically this axle is a non-rotating member, but this particular definition is applicable to a few cases like railway wagon. Next is spindle. So spindle is simply defined as a short shaft. Spindles are used in all machine tools such as small drive shaft of a lathe or the spindle of a drilling machine. You can see over here the photograph of lathe machine. Okay, here this particular member is known as spindle, which is a very small shaft. Again, it also supports over here the gear assembly. Okay, so you might have seen this when you have operated lathe machine. The next is counter shaft. It is a secondary shaft which is driven by the main shaft and from which the power is supplied to a machine component. You can see over here there is a clutch, and this is your main shaft. Main shaft is also supporting few gears. Now few gears are connected with the another gears. Now another gears are supported by means of the another shaft. So this is the secondary shaft. Okay, if this will rotate in forward direction, definitely this will rotate in reverse direction. And this reverse directional gears, okay, they are supported by means of this shaft. So if this is forward, then this is counter. So that's why usually we call it as a counter shaft. This basically used in multi-stage gearboxes. Next is line shaft. A line shaft consists of a number of shafts which are connected in axial direction by means of couplings. You can understand here this all shafts are connected in axial directions, and they are supporting different types of components. Okay, here it is supporting a pulley. Same way it can support to gear also. Now pulley is again operating the another machines. So line shafts are popular in workshops using group drive. In group drive construction, a single electrical motor will operate, and a number of pulleys are mounted on the line shaft, and power is transmitted to individual machine by different belts. But here if you can see, if one member or one machine will fail, say here this pulley operates to the to one machine. Now if this one machine will fail, then we have to we have to change the position of this pulley, or we have to change the belts. So otherwise the whole assembly or whole particular assembly will fail. So again, if there is a problem with the alignment or distancing between two shafts, then definitely there will be a vibration. So that's why this particular type of configuration used in old days. Nowadays people are not using this type of line shafts. Next is transmission shaft. In general, these all shafts are known as transmission shaft, which actually transmits the power between source and the machine. The counter shaft, line shaft, overhead shafts, all generally factory shafts are transmission shafts. And since it supports to pulley gears, therefore it can subject to bending as well as twisting. So this you can see, this is a crankshaft. You might have seen this as a crankshaft. Now this is a special configured shaft because of change in its shapes. Okay, so this is transmission shafts. Now, so these are the type of shafts. The spline shaft, usually they are different than this type of shafts. The gear tooths are generally made onto the periphery of this type of shafts, which is a special type of shaft. We can call it as a spline shaft. These are the standard sizes of the transmission shafts: 25 mm to 60 mm with 5 mm steps. 5 mm is the length, you can say. Overall, 60 mm to 110 mm with 10 mm steps. You can apply same way to others. And the standard lengths of the shafts are 5 meter, 6 meter and 7 meter. So sometimes you can see this as steps are changing. Okay, the fillets are generated to control the stress concentration factor. Now let us try to understand the forces acting on the shaft. Here, for example, there is a one configuration where shaft supports the gear. So here the shaft is only supporting one gear. These are bearings. So we can understand there is always a self weight of the gear. So this weight definitely will try to apply a force in the vertical downward direction. So that force you can see over here. This is a transverse load. So this you can say that this is the weight of the gear. Now to oppose this weight, definitely there will be a two reactions. Okay, that's why we call it as a transverse reaction, which is actually given by the bearings. So this is from the supports. Okay, so this is a transverse reaction. This is again the transverse reaction. Now because of this type of loading which acts on the which acts at the center or somewhere else, this particular shaft will behave like a beam. You can understand, because of this bending phenomena will exist with this shaft. Now addition to this, shaft is also sorry shaft is also rotating. Now because of this rotation, definitely there will be a torsional forces exist. Now this torsional forces, just to oppose this, there will be another torsional forces given by bearings. So this is balancing forces or reactions given by the bearings. Now sometimes the bearings, like cylindrical bearings, okay, in those type of bearing cases, the axial thrust will also introduced. Okay, so this axial thrust is given from the bearings, from the supports, okay, to the shaft. So shaft can subject to bending as well as torsional load as well as axial thrust. So these are the type of loads will act on the shaft. Now when we try to design the shaft, obviously we have to focus on material, then we have to decide its geometry, then we should understand the stresses and strengths. Again, definitely it is a rotating part, so fatigue will come into picture. Then we have to understand deflection and rigidity, where we will understand bending, torsional, twisting, okay, and others. We'll try to understand the vibration also, where critical speed will comes into picture. When we focus on materials used for the shaft, the material used for the shaft should have following properties. It should have high strength, good machinability, have high rear resistance properties, and good ductility. Basically, the generally carbon steels of various grades they are used for material of this. The alloy steels have higher strength, hardness, and toughness. Also, high value of hardness and strength can be achieved for components with large section diameters. That's why alloy steels possess high resistance to corrosion compared to plain carbon steels. Usually, this type of alloy steels are used to make the shafts. These are again the similarly the various types of materials and their ultimate strength and yet strength. Now I'm stopping here. From next lecture we will start with stresses developed in the shafts and will try to understand the shaft design based on torsion.